Hey guys, welcome back. Mr. Math here. Looking at AMC 12 2021B fall, problem number 16. So this one says, suppose A, B, and C are positive integers such that A plus B plus C is 23, and greatest common divisor of A and B plus greatest common divisor of B and C plus greatest common divisor of C and A is equal to 9. What is the sum of all possible distinct values of A squared plus B squared plus C? Okay, this one is pretty tricky. So for this one, just looking at my notes really quick. I basically, I don't really have a great strategy for this one. Like, it's kind of a brute force method, to be honest with you. At first I started looking at like possible numbers for A, B, and C, like in such a way that they would sum to 23. But there's just too many possibilities, right? And it's not going to get you very far because there's just too many cases. But there's a lot fewer ways to sum up to 9. So I started out listing possible values where the sum would be 9, right? Starting with 1, 1, 7, right? So like referring to like these three values as being 1, 1, and 7. And I tried to think like, is it possible to create a triplet of numbers that sum to 23 where two of them have a common divisor of 1, two of them have a GCD of 1, and then two of them have a GCD of 7. And it turns out that this situation is possible. Because notice how nowhere in the problem does it say A, B, and C are distinct positive integers, right? It doesn't say the word distinct. So A, B, and C can be repeats. So if you have the situation where you have 7, 7, and 9, A is 7, or let me just make sure, A is 7. Yeah, it doesn't really matter, right? So let's say A is 7, B is 7, C is 9, right? Well, the GCD of 7 and 7 is 7. The GCD of 7 and 9 is 1. And the GCD of 7 and 9 is 1, right? So we created a situation where this equation's true, right? And 7 plus 7 plus 9 is 23. So therefore, this case works. So we can look at 7 squared plus 7 squared plus 9 squared, which sums up to 179. Okay, so that's one case. Can we find another case? So then what I started doing is I started looking at like different situations and just it's like trying to decide if it's possible, right? So another case could be, what about 6, 2, 1, right? And what I'm referring to is like the values of A, B, and C. So can we have A is 6, B is 2, C is 1? And I tried to find situations where this can be true. Well, it's not that bad because if you think about it, in order for a GCD to be 6, you need two of the numbers to be multiples of 6. So you can start by saying, well, what if two of the numbers are both 6s? Well, then your third number would have to be 11. But this clearly doesn't create, this situation, right? The GCD of 6 and 11 is 1. So it would be 6, 1, 1, not 6, 2, 1. Right, so that wouldn't work. But then what if we had 6, 12, 6, 12, and then I guess 5, right? Would that create this scenario? No, right? Because again, GCD of 6 and 5 is 1, and GCD of 12 and 5 is 1. So we're not, so in order for this to work, I don't think this could work because if two of the numbers have a GCD of 6 and then, so let's say, for example, like A and B have a greatest common divisor of 6, right? So that means that A and B are both multiples of 6. And then let's say the greatest common divisor of B and C is 2. Well, that would mean that A, B, and C would all have to be even. So therefore, their GCDs would all have to be at least 2. So you can see that this situation is not even possible. So it's not possible for two of the numbers to be even and then the third number to be odd. Because if two GCDs are even, then that means all of the numbers have to be even. So that's sort of a strategy you can use to think about like what situations can and cannot work, right? So then basically like I tried a whole bunch of different scenarios. Like, well, then I looked at like so I had 621, and then I saw like what about 522? But again, this can't work for that same reason I just said, right? You can't have two of them be even and the third one be odd, because if these two GCDs are even, then that means each of the three numbers has to be even. So it's not possible for then. Actually, wait, sorry. Yeah, then any GCD would have to be even because they're always going to share a factor of two in common. So it wouldn't make sense that like two of them would then have an odd greatest common divisor. So then this situation is not possible either. But then what about 531? Can that work? Can you have the situation where two numbers GCD is 5, two numbers GCD is 3, and then two numbers GCD is 1? The answer is yes. Because if you have the scenario, let's say A is 15, B is 5, and C is 3. GCD of 15 and 5 is 5, GCD of 15 and 3 is 3, and GCD of 5 and 3 is 1. So that'll work. So that means this pair works. So we have 15 squared plus 5 squared plus 3 squared. That sums to 259, right? Okay, so we found two situations that work. Can we find any other cases that work? The answer is no. Basically, I tried a whole bunch of other scenarios. See, basically what it means, because 9 is odd, right? 9 is an odd number, right? So if you think about it, how can you add three numbers to result in an odd? Well, you're either going to do odd plus odd plus odd, or you're going to do even plus odd. But notice how we just said that this situation is not possible, because two numbers, you can't have like two pairs have an even GCD and then the third pair have an odd GCD. It just doesn't work, because then all of the numbers have to be even. So they all have to share a factor of two at least, right? So this situation is not possible. So the only situations that could be possible are the odd odds, which the only ones that exist are 711, right? 711, 531, 333, and then that's it, because then the others would just be repeats like 135 and 117, right? But obviously this situation is not possible, because the only way that this works is if all three of the numbers are 3, right? Yeah, because um well, actually I guess you could have, well, they don't, the only way that could work is, let's say if you had you're going to have two threes, but if you have two threes, um the third number would have to be 15. No, sorry. The third number would have to be 17, right? In order for that to work. But the GCD of 3 and 17 is 1, not 3. So that actually wouldn't work. So that scenario would not work, right? So that can't happen. The other case would be, well, what if we had 3, 6? Now, then the third number could not be a multiple of 6, because then the GCD of that number and 6 would be 6. So then this number would have to be either 9, 15. Well, what number would we need if we had 3 and 6? If we had 3 and 6, that's 9. We would need 14, but 14 is not a multiple of 3, so that doesn't work. Right? So basically, it's not going to work because 23 is not a multiple of 3. So it's not possible for the 3 numbers to all be multiples of 3. So that's why this situation can't even work. So that means these two situations are the only ones. So we've exhausted all possibilities. Right? So 179 plus 259 is 438. So the answer is B, 438. So pretty tricky question. You know, pretty heavy number theory, which is not something that's typically taught in high school. So, you know, it's some pretty advanced stuff for high school students to do, but also a very fun question in my opinion. I love problems like that. So anyway, in my next video, I will be going over number 17. All right, I'll see you there.